Welcome. In this video lecture, we are looking at the book Think Python, How to Think Like a Computer Scientist. We're looking at the second edition. The authors are Alan, Jeffrey, and Chris. I'm going to be doing video lectures. My name is Arthur Solomon. I'm going to be working with you throughout these videos. Thank you. Exercise 7.3. So we are going to be doing a calculation to estimate pi. The author has already given us the solution for this formula. So we're just going to run through what it should look like. Let's jump into our windows to see what we can do. Alright, so let's go ahead and open up our PyScripter. Alright, let's go ahead and delete the default portion of it. Alright, so first of all, we need to import our math. From there, we need to go ahead and we need to worry about factorials recursively. Like, that's going to be one of the big ones. So we're going to go ahead and do a function for that. Factorial. We will give it the value of n. We will be calculating if n is set to 0. Return 1, else we will be doing a recursive, which will be set to factorial n minus 1. We will be setting the results equal to 1 times our recursive. Oh, I did the wrong bracket there. And then we will return our results. Alright, so what does this mean? Well, recursive factorial is essentially when we have factorial is a non-negative integer, which we typically will denote as n exclamation point. It's the product of all positive integers less than or equal to n. So for example, 0 exclamation point is 1. If we have additional numbers, like, they just keep adding up. Factorial of 4, for example, 4 exclamation point is equal to 24. So that would be 4 times 3 times 2 times 1. If we had 5 exclamation point, that would be 5 times 4 times 3 times 2 times 1. And so forth. You have to love the math component in programming. So that sets care of our recursive factorials. So now we can get to the actual main function that we need to look at. Alright, so our function was called estimate pi. So estimate pi. And this will be computing pi. So I did a comment so we know what it's doing. Well, again, it's computing an estimate of pi. So from here, we need to set a few variables. So we're going to be using total. We'll set that equal to 0. We'll be using k. That'll be set to 0 as well. So looking at the formula, we have a factor is equal to 2 times our math square root of 2, all of that divided by 9801. And again, I'm pulling this out of the PowerPoint. I'm using this formula. So we just did this part right here. Alright, so that's the first part. Next part is we're going to do a while loop. So while true, we have a number, and that will be our factorial for our 4k, because you'll notice 4k exclamation point. So that will be factorial 4 times k and all of that times 1103 plus 26390 times k. We have our din number, which is our denominator, is our factorial, which will be k, and we are cubing it, or sorry, we're power 4, so times exponent of 4 space. We are timesing that by 396, and that will also be to the power of 4 times k our term will be set to our factor, which is times our numerator divided by our denominator. Oh, that would be factor. So the term equals factor times numerator. Alright, perfect. And our total is going to be plus equal sign our term. Plus equal sign our term. So we're not quite done yet. Again, we wanted to get it to the last term is smaller than 10 to the power of negative 15, or smaller than 1e negative 15. So we need to do that. So if our term is less than 1e minus 15, break. Otherwise, k is going to be plus equals 1. We will go ahead and do a return value, 1 divided by our total. And at the very end, let's print our results. So our total is going to be representing pi. We want to make sure that we're being able to do our factorials correctly. Here we have the second portion of our calculation. Here we have our first part of our equation. These are set to 0 at first because this is going to loop until it's no longer true. Once it's done, it will break it and then return our total value being pi, and then this will be 1 divided by pi, and that will be what we actually return. So let's run it. Let's see if my typing skills was correct. Have to love when you fat finger. Din, denominator. There our calculation is. So make a new module so we can kind of clean this up a little bit. Alright, so I made a new module, And again, part of this is being able to add in some comments so that we know kind of what's happening. So what's the purpose of all of this? So first of all, our factorial will essentially compute the factorial of a recursive n value. I re-put back the computes an estimate of pi. Alright, so I'm going to clean this up a little bit better. I'm going to go ahead and the estimated value of pi is space. I will run it. That way I get, some meaningful output. And our code is documented. So that's all for this exercise. We've completed the exercise and we've checked our results according to our book. Questions, comments, let me know. That concludes this chapter. If you have any questions or concerns, please feel free to reach out and leave me a comment or a question. I'll try to get those answered as quickly as I can. Again, thank you, and I look forward to working with you in later modules.